problem, you must understand it. So let's talk about it. Worldwide, there is an epidemic of poor metabolic health. Over half of all adults around the world, over half of everyone you know, has some form of insulin resistance. It is the most common health disorder worldwide. Now, insulin resistance is a big problem, not only because of how common it is, but also because of what it causes, where insulin resistance can become diabetes, which you've heard about already. Insulin resistance can become heart disease. It can become problems of fertility, where if a man and woman are having trouble having a baby, sometimes it is a metabolic problem, but also problems of the mind, problems that scare us, like Alzheimer's disease, migraine headaches, and even depression have a metabolic or insulin resistance foundation. So when you're talking to your friends and you mention insulin resistance, you mention that insulin resistance plays into all of these chronic diseases. Now, your friend may ask you, what is insulin? I want you to have an answer for them. So insulin is a hormone that comes from the pancreas. Within the pancreas, which is right beneath the stomach, there are these cells called beta cells. And beta cells wait for a signal. And when blood glucose levels start to go up, then the beta cells will say, oh, I know what to do, and they will release insulin. And when they release insulin, insulin goes through the body and knocks on the doors of cells like muscle cells or fat cells. And it will tell those cells to pull in the glucose. And now the blood glucose can come down. Now, this is insulin's most famous effect, but insulin actually does all kinds of things. It tells all kinds of cells to grow. It tells fat tissue to grow. It regulates our electrolytes in our bodies. Insulin does all kinds of things. Its most famous thing is that it will push down glucose. So glucose and insulin have a very, very close relationship. And when glucose is going up, then insulin will go up. I want you to understand why this is important. If you're talking to your friends and you're telling them about how glucose is affecting insulin resistance and insulin, why does this matter? Well, let's put the glucose away for just a moment, but we're going to come back to glucose in just a few moments, and let's just talk about insulin. Insulin, when it is elevated, plays into insulin resistance. There is no such thing as insulin resistance and all of the problems that it causes if there isn't also elevated insulin. These two things always come together. Now, as I have given some talks for Unicity, which I always love, I have been interested to see how you are interested in the connection between insulin resistance and depression. This is a very, very delicate topic, but it is very important for you to know that there is a lot of scientific evidence suggesting that in some instances, depression has a connection, which is insulin resistance. And I wanted to just take a moment and make sure you were aware of how that happens. So that if you mention this to your friends, that your friend will say, well, how is depression connected to insulin resistance? Now you can answer them. So the brain, you can see my brain very well because I have nothing covering it. The brain has a very high metabolic rate. It is very hungry. Hopefully your brains are very hungry right now because you're listening and learning so much. But the brain always wants to pull in energy. And one of those energy sources is glucose. So glucose is fueling the brain. The brain is like an engine and it just keeps running. It needs lots of fuel. Insulin opens the door to allow the glucose to come in. And so when the brain is getting very hungry and it wants glucose among its fuels, it needs insulin to help the glucose come in. But what happens when insulin isn't working very well? What happens when the brain becomes insulin resistant? Now the brain can't get enough of its energy from the glucose. So the glucose coming in to fuel the brain isn't working very well. The brain starts to go very hungry. Its energy use starts to go down. And in some people, that manifests or that causes depression. In other people, it may cause migraine headaches. In other people, it may cause a forgetful mind or something like early stage Alzheimer's disease. These seem like different diseases, but they have one thing in common. The brain is going hungry because insulin isn't working well. In other words, the brain has become insulin resistant. Now, if you've been telling this to your friend may say, well, where does insulin resistance come from? You need to know where it comes from in order to explain this to them. The most common cause of insulin resistance is too much insulin. It's almost like when we are hearing a loud sound for so long, we start to become deaf to that sound. We don't hear it as well anymore. When the body has been so loaded with insulin for so long, the body stops listening. It becomes like a naughty little child. And I know a lot about that because I have 3 of them at home. So too much insulin causes insulin resistance. As one goes up, so too does the other. Now, if too much insulin causes insulin resistance, now your friend may say, well, where does all of that insulin come from? Why does my body have so much insulin? And this brings us back to glucose. Let's look at what happens when a person eats fat or protein or carbohydrate. Those are the 3 macronutrients. And in English, that word macro means big. They're the big parts of the diet. So you teach your friend about the macronutrients, fats, proteins, and carbohydrate. And then you tell them, when a person eats fat, there will be no insulin response. When a person eats protein, there may be a small response, but it's generally quite modest. But when a person eats pure carbohydrate, then all of a sudden insulin goes up by 10 times, and even at its fastest, it'll take 3 hours before it comes back down to normal. So that matters. It matters even more because when you look globally at the amount of what people eat, over 70% of all calories worldwide come from carbohydrates. And usually this is refined carbohydrates, so sugars and refined starches. So not only are we eating most carbohydrate, but that also happens to be the one thing that keeps insulin the highest. Now, I'm not done talking about carbohydrates because they can become a problem. In our bodies, when we eat glucose, at any moment, we have only about 1 teaspoon, just 4 grams of glucose in our entire body. That is in our blood. We only have 4 grams of glucose in our blood. That is very, very little. But then what happens if we go eat a chocolate bar? We go eat some candy. A normal chocolate bar has 10 times more glucose in it than in my entire blood. If I take all of that glucose into my body, that will increase my blood glucose so much that if it stays high, I would die. It just from the sugar in 1 chocolate bar, 1 candy bar, it will increase the glucose level so much that it would make a person die. And so we cannot keep the blood glucose levels so high. And we have someone who can come and help. If blood glucose is going up, remember there's a hormone that can come from the pancreas to help the blood glucose come down. Do you remember the name of the hormone? Yes, it's insulin. So insulin now is a hero. It's a savior. In this role, insulin is saving our lives by not letting our blood sugar or blood glucose be too high for too long. So the glucose starts to come up, insulin will come up, and it will act to push the glucose down. Remember, because it opens doors and allows the glucose to come out of the blood. and so it saves us. However, this can happen too often, too much. So you'll remember, most people, the average global diet is over 70% carbohydrates. And so when you keep eating and your glucose goes up and the insulin's coming up, then insulin resistance starts to follow. So a person eats glucose, insulin goes up. They eat more glucose, insulin goes up even higher. They need more and more insulin, and they get more and more insulin resistant. Okay, so far I have been talking a lot about insulin and insulin resistance. I worry that you might be getting a little tired of insulin. So for the first time ever, in any Unicity talk I've ever given, aren't you so lucky? For the first time ever, I want to talk about some of the specific effects of glucose. What I've been talking about so far is that glucose only matters because it pushes up insulin. But that's not entirely true. Not that I've been tricking you. That's all true and very important. But it's also important for you to understand another effect of too much glucose. Because yes, too much glucose causes too much insulin, which causes insulin resistance, but also glucose has this ability to be kind of sticky. When glucose is too high, it will start binding. It will stick to various molecules in the body, including proteins. And when glucose gets stuck to something like a protein, it starts to damage whatever it is stuck to. It messes up the shape. And now this thing, in this case, the protein was going to go through my blood and do something important. When glucose comes and binds on it and sticks onto it, now it can't. So when glucose binds, this is a process that is called glycation. This is a new word for some of you, but it's something I want you to remember so that when you go talk to your friends about the metabolic storm, I want you to be able to talk about insulin resistance. Now I also want you to talk about the problems of glycation. And glycation happens not only at proteins, it also can happen at fats, it can happen at DNA. Within the nucleus, I'm sorry translators, within the nucleus of the cells, the glycation can damage DNA and cause mutations. Now, you might be thinking, okay, Professor Bickman is being a little dramatic. Let me just help you understand how relevant this is. And never forget insulin resistance, but now we've added to the story. Because when the cells of the brain start to get too much glucose and they get glycated, they suffer. The heart can suffer. The kidneys can suffer. Even our bones can suffer. But when the brain experiences too much glycation, brain problems happen, including Alzheimer's disease. So there is substantial evidence to show that Alzheimer's disease is partly a consequence of too much glucose. And the glucose is getting stuck, it's getting sticky, and it is damaging the brain's ability to function. Now, what about the heart? When the heart muscle starts to get too much glucose binding to it, it directly damages the muscle, causing heart disease. In fact, the problem goes even further when it comes to the heart, because the blood vessels, if we look at the blood vessels in a person, the blood vessels start to have some glycation as well. And then the blood vessels get damaged. And then you start to have things like atherosclerosis and other problems. So more heart disease. Now what about the kidneys? The kidneys actually, as from a metabolic scientist, it's interesting to note that they actually have the highest metabolic rate of any part of the body. But when there's too much glucose coming to the kidneys, they get damaged. And now the person has kidney disease. And even the bones, when the bones and all their proteins start to have glycation, now the person starts to have osteoarthritis, where the bones start to get weaker and more and more fragile. This fly wants to learn about insulin resistance. Pesky fly. It's a good student. He just wants to learn. I can't blame him. Okay, now, you look at these tissues, the brain, you look at the heart, the bones, And it's easy for us to think, well, that's okay, because I can't see those. What we can see is the skin. Now, I know many of you are very interested in looking good. I don't care as much as I used to. When you're a freckled old man, it's okay to not look good. But some people want to look good. Yeah, I do too. I want to look good. But even on the skin, with all of the proteins and the collagen of the skin, there's evidence to show that when the skin has too much glycation, it starts to cause the wrinkles on the skin. So this could make someone start to look much older. So as the glucose levels are higher and higher, it starts to make more and more glycation, and then the person starts to get more wrinkled and begin to look older than they are. None of us want that. We want to look young. And so we want to control our glucose to control our glycation. So we have all of these tissues, the skin, the brain, the heart, and many, many more. All of them start to suffer when glycation starts to go up. But there's one other cell, and it's actually the most famous of all of them, that experiences some glycation, and that is the red blood cell. So the reason our blood is red is because of the red blood cells. And within the red blood cells, there is this complex structure, these proteins that we call hemoglobin. And hemoglobin its most famous job is to carry oxygen. So when I am taking a breath, I'm pulling in the oxygen. How do I get that oxygen to my muscles, to my heart? It's because the blood cells will take that oxygen and bind it. And it will carry the oxygen down to wherever I need it, down to my muscles, everywhere it needs to go. However, when the hemoglobin has had glycation, now it doesn't fit the oxygen very well. So now our red blood cells, whose most important job is to carry oxygen, they can't carry the oxygen as well as they used to. That is a big problem. This is something that is called hemoglobin A1C, or HbA1c. That is a percent or a number that reflects how much glycation do I have on my red blood cells. And that is a number that we can use to say, how much glycation do I have in my entire body? You cannot measure the glycation in your brain. You cannot measure the glycation in your heart, but you can measure the glycation in your red blood cells. Have some of you ever had your HbA1c measured? I bet you have. It's a very common measurement, and it's a good measurement of glycation. Now, I want you to pay attention to this, because here I have the blessing, I'm such a lucky professor, to speak to students from around the world. And so I wanted to understand, how do people around the world have different levels of HbA1c, or hemoglobin glycation? Now, before I mention that, I want to mention the numbers. So usually, HbA1c is presented as a percent. How much of my red blood cells, what percent of my red blood cells has undergone glycation? And if you can see these cutoffs, a good range is considered anything from 4% up to the mid 5%. And then we go up higher to the mid 6s, and that is usually considered the cutoff. If someone has an HbA1c that is a 6.5% or higher, then we say they have type 2 diabetes. They have diabetes. We want it to be lower than that. Now, this has me come back to my point from a moment ago. We have so many people from so many beautiful countries. How are different people affected by HbA1c? So I was able to find multiple studies that compared these distinct populations: Europeans, Latinos, Asians, African, and then Arabic populations. All compared to European populations, all the same. Imagine if we had these 5 people, and they were all the same body size, same height, same weight, is matched with fiber. Now all of a sudden you took that very, very high curve and you pushed it down. They still ate the same food, but by just matching that food with some glucose, with some good fiber, then they can bring the blood glucose down. Now your friend may say, well, that sounds wonderful, but I don't know how to get good fiber because not all fiber is the same. Not at all. There are lots of different types of fibers. So your friend may say, well, how can I get a good fiber? Do you have a good fiber that you can help them with? Yes, you do. You have a very good fiber to help them with. And you say, this has been formulated just for this, just to help bring your blood glucose under control. In fact, this will help balance your blood glucose. Now, they say, your friend will say, okay, wonderful, thank you. Is there anything else I can do? One more effect is chlorogenic acid. You can teach your friend that there is this molecule in some plants, and this is a quote from a scientific study. This molecule has been shown to not only help bring down fasting levels of insulin and glucose, but also when someone eats glucose, it pushes down that glucose level, just like fiber does. So chlorogenic acids are acting in a similar way. Now your friend may have never even heard of chlorogenic acid, and they will say, well, how can I find some chlorogenic acid? Do you have a source, do you think? Yes, you do. You have a tool that you can help your friend with, and you can say, I have this product that has been designed called Unimate to be enriched with chlorogenic acid, and one of its benefits among many is going to be to help your glucose and your insulin come under control, because we are trying to balance blood glucose. Now, this is the insulin curve, and now the purple line I'm showing you is what the glucose level is looking like. So when someone eats a lot of glucose, the insulin went up, but of course the glucose went up first. And at the top, when glucose goes up, it activates glycation. And we have all of those problems that we talked about before. So when we have an average individual who's eating a lot of carbohydrates all the time, their blood glucose levels are going crazy all day long. That is a term called glycemic variability. And this is high glycemic variability. Those levels of glucose go really high and then really low. The more a person has glucose levels that are going like that, the more risk they have of heart disease, of cancers, of Alzheimer's disease, depression, diabetes, and many more. So you are telling your friend, we cannot have glucose coming up and down all day long. We need to take these big spikes, and with a little bit of balance and a little Unimate, you can bring that under control. You can start to take the highs and the lows and start to press them down. Remember, this is not even changing the diet. You can balance blood glucose better by using these two tools to help your friend feel great. Okay, so that was all step one. That was the first part of this process. Balance blood glucose. Fiber in balance helps bring it down. The chlorogenic acid in Unimate also brings it down. They both work